I've done my rough titration, but now I want to do a more accurate one. So I borrowed this stuff from school. This is a volumetric pipette filler. This thing is a burette and a burette stand. You know that already. That's how you spell them. Don't spell them wrongly, because you'll lose marks if you spell them wrongly. And it's not that. That's the biology one, all right? That's completely different. Remove that one from your brains unless you do biology. Pipette, burette, all right? So what I need to do, I'm going to get my sodium hydroxide into there, and I'm going to use my pipette filler. So we'll just suck this into here, nice and slowly. If you do it too quickly, you run out of suction, as it were, and it doesn't work very well. So do it nice and slowly. Get our sodium hydroxide in, and there we go, 25 cubic centimetres. In we go. So that now is exactly 25 cubic centimetres of sodium hydroxide in there, or it will be once it drains in. So last time we did it with 10 cubic centimetres, this time we're going to do it with 25. There we go, and it goes. Phenolphthalein, got to put our indicator in, otherwise nothing's going to happen. There we go. Great, that's what we want, nice pink colour. And I'm now going to titrate it with acid from the burette. So what we do is, it's not exactly 0 at the top, so I'm going to open the tap and we're going to let it run in. And I've done a rough one, so I know roughly how much it should use. So I'm going to let it run, and then I'm going to stop it just before the amount that I think it should be. So letting it run, letting it run, letting it run. We'll stop it every so often, give it a bit of a swirl. Not much happening so far, which is what we'd expect. So we'll keep going. And something should be happening fairly soon, hopefully. So I'll just keep it running. And we can see that it is gone. Okay, so that is at 16.70. That is my rough titration. So what I'm going to do now is I'm just going to do another couple of these, and I'm going to stop it just before that point until I get to it, just before I know it's going to turn, and then go drop by drop. Just turn the tap drop by drop, and then I'm going to get a very accurate measure. I'll do that 3 times, and I will hopefully get some concordant titers. Concordant titers are when they're within 1/10 of a centimetre of each other, and then I'm going to sum those together, take the average, take the mean, and that is going to be my titer that I'm going to use for the working out. And we'll have a look at the working out now. See you later. Okay, now we're going to do our accurate titration. We've got our volume of acid that we used in the titration. I did 3 different titrations and I took a mean. So the idea is to get 3, they're very close to each other, and that way you can rule out any anomalies. So it's a more accurate way of doing it. So our volume was 15.45 centimetres. For the sodium hydroxide, we had 25 cubic centimetres in our conical flask, which equals 0.025 decimeters, and the concentration was 1 mole per decimeter. So we can find out the moles of sodium hydroxide just by timesing those together, because mole equals vol times conc equals vol times conc. If we look at our triangle up there, that will tell us that. So if we times those two together, 1 times 0.25 is going to give us 0.025 moles of sodium hydroxide. That is the amount of sodium hydroxide we've got. Now we need to look up here and look at our molar ratios. So we've got, again,
a ratio of 2 to 1 due to the chemical equation up the top here. So if I've got 0.025 moles of sodium hydroxide, I must have half as much. So we must have 0.0125 moles of sulfuric acid, because 2 of those is going to react with 1 of those. So 0.025 moles of sodium hydroxide is going to react with 0.0125 moles of sulfuric acid. So now for sulfuric acid, I've got my moles, tick, and I've got my volume, tick. The moles is there, 0.0125. The volume is up here. That's what we actually measured. That's what we got into the burette and then dropped in very slowly. So we know that's pretty accurate, 0.01545. And then we can just plug them in because we want the concentration, and the concentration equals moles over vol, which is 0.0125 divided by 0.01545 equals 0.81 mole per dm cubed of H2SO4, and that is our answer. Pretty close to the rough one.